Yeah. Mahesh, my voice is audible?
Yes, you're audible.
Yeah, we can start. Good morning. Good morning, good afternoon, good evening, participants from all over the world. Today we are going to have a session on data engineering on GCP. In this session, we are going to have a high-level introduction on different set of data engineering tools used in GCP. And the speaker of the day is Mahesh Babar. He is a platform engineer at top Fortune 500. Moving to fifth IR, fifth IR stands for Fifth Industrial Revolution. What we are, who we are. We are over hundreds and thousands of strong community of technologists from all over the world. We deal with technical sessions and consultations and projects on multi-cloud strategy, data science and AI, blockchain and extreme engineering. We also help technologists to share the learning and get opportunities through our partners worldwide. This is the infography of how we are going. We have 9 events in the queue, and we have totally 1,000+ sessions we have conducted, and we have 300+ speakers associated with our platform, and we have offered 8,000+ certificates through our platform www.fifthia.com, and we have 25,000+ members registered in our platform. These are the few master mentees and MVPs associated with our platform. We are academic partner of Alibaba Cloud. These are the few courses which we have done in association with Alibaba Cloud. You can get the certification directly from Alibaba Cloud, and the link for this particular certification is provided over here. How we can help you? We can help you to build your knowledge and digital presence, and we will help you in odd ways when we are looking for jobs through our community. All you can access through our platform www.fifthir.com. As a part of our community, we are going to provide a free level 1 certificate for all the participants, and you can access the certificate by providing the secret code, which we will provide at the end of the session. And the speaker of the day is Mahesh Babar. He is a platform engineer at top Fortune 500. He has associated with different roles in the organization, such as platform engineer, Python developer, and front-end web developer. He has done a couple of contributions in Grill Script Summer of Code, and he is a member of Google Developer Group. You can see more about him in the given LinkedIn profile. And now, without any ado, I'm going to pass the session towards to Mahesh Babar.
Okay. Thank you, Gavaskar. First of all, thank you, Multi-Cloud, for your technologies for giving me opportunity to talk on the data engineering in GCP. Hello, all. I'm Mahesh here. Today, I will be speaking on the data engineering on GCP. Let me share my screen.
Mahesh, I think
Yeah.
you can switch off the video since some distortion is there.
Okay. Thank you. Uh, can you see my screen?
Yeah.
So you're able to see my screen for the slides, right?
Yes. Yes.
Let's go ahead, start the show. So today we will discuss on the data engineering on the GCP, and the agenda will be the what is data engineering. After that, we will focus on the skill set that we are required for the data engineer, and after that we will talk more on the GCP services which is required for the data engineering. And at the last, we'll see the how to build a scalable data analytics pipeline. So first, what is a data engineering? Like data is related to the information, right? So data engineering is mostly information engineering. Data actually drives the operations from the small business as well, and so the from the large businesses as well. So businesses use the data to provide the relevant inquiries that range from the customer interest, and it will go to the product usability. So without a doubt, data is important part of scaling your business and gaining valuable insights, right? So data is like software approach for the developing information system, so that we will store the data, we will analyze the data. So to be clear, data engineering is mostly surrounded with the sourcing data and managing data with the help of like loading and transforming from the various systems. So this process ensures that data is useful and accessible. Talking about the complex task in the data engineering is making the raw data usable to users, like making the raw data usable to data scientists or the groups within the organization, and or the clients, we can say. And data engineering is involves in the wide range of tasks, like data modeling, data integration, and data transformation, even sometimes for the data quality check. So here we can say we have different data sets is connected with the data engineering. Even we can play with the pre-processing of the data, classification of the data. We can store relational, non-relational database, and even we can create the statistics, analytics, and we can at the last evaluate the data. So moving on the next point, like what is data, why data engineering is important, right? So data engineering is important because it allows businesses to optimize the data towards the usability. So we can take example over here, like increasing your understanding of business domain knowledge. So if you want to increase your business knowledge, and if you have the data, you can go with the help of data engineering. After that, we can simply bring data together in one place, and we can integrate with the another different integration tool, right? So whether the business teams are dealing with the sales data or the analyzing their life cycles, data is present every step of the way. So we need to play with the data, we need to analyze the data, and we need to create somewhat which is relevant to us from the data. So last, which is bit especially stresses the importance of the data engineering skills, is it when it comes to the organizing huge amount of data. So let's move ahead. So now we'll talk about the skill set that is required for the data engineering. First of all, you should have strong foundation in programming language, like at least in Python, and if you have knowledge in Scala and Java, that's good. And most important is you should have proficient in SQL, and also like you should know about the NoSQL databases such as Cassandra or MongoDB, or somewhat like HBase. So you should have clear understanding on the concepts like data warehousing, including the ETL flow. So ETL means extract, transform, and load. Over here we can see extract, we are taking the data from the databases, files, SaaS applications, and different application events. We are extracting the data from the different sources, and after that we are transforming the data in the staging area. We'll talk about this after some time. And at the last, we are loading the data into data warehouse, which is structured, where we will store all the structured data, process data. And at the last, we will simply run the SQL queries related to the our data, and we'll gain the insights from that data. Now if we are talking about the ETL process. This is the ETL process that just simply extracting, transforming, and loading the data and getting the insights from the different data. Moving ahead for the next skill sets, we have big data technologies, right? So Hive, Hadoop, and Spark. Knowledge of distributed computing technologies like Hive, Hadoop, or Spark is becoming increasingly important for the data engineers because it is used prominently in different organizations. And when we are talking for the cloud computing, especially you should be familiar with cloud based storage and cloud computing platforms such as AWS, GCP, and Azure, which is too much important. Moving ahead for the version control, so you should have proficiency in version control systems such as Git. So Git is example for the version control system. Understanding the concept of branching, merging, how we can branch the two branches, and after that how we can merge, how we will tag the essential, which is essential. So version control, also known as source control, which is actually the practice of tracking and managing changes to software code, right? So we are actually managing the code with the help of Git. And at the last, like, it is a software tool that helps and manage and changes the source code, and even we can move and go to back our versions as well if we want. Next point is our data pipelines. So data pipelines, we should have understanding how to build data pipelines using tools like Amazon Kafka, Apache Airflow, and Apache Kafka, which is little bit critical. So what is actually data pipeline? Let's assume that you have three tasks, which is task 1, task 2, and task 3. So you should schedule that pipeline, like first we'll run the task 1, after that task 2 and task 3. So in that way, in that scenario, the data pipeline comes in the picture, so that we can use Apache Airflow or the Apache Kafka over there. Moving ahead for the data lakes and data warehouse, this is important part for the data engineers. So if we are talking for the data lake is a vast pool of the raw data, and a data warehouse is a repository for the structured filtered data that is already been processed for the specific purpose. So data lake consists of raw data, and data warehouse consists of processed data. And data lake must used for the raw unprocessed data, while data warehouse stores the processed and refined data. Okay, so data lake are often difficult to navigate by those unfamiliar unprocessed data. We are unable to navigate to the unfamiliar and unprocessed data. It is little bit difficult. And talking about the raw and unstructured data usually requires the data scientists or specialized tools to understand and translate it for the any business specific business use case. And most importantly, at the last, you have processed the data, you have the all the data which is processed, but you should have the visualization of that data. So you should have clear understanding of the data visualization tools like Tableau or Power BI, so that you can use that tools with your data. And at the last, which is important, is soft skills, that you should be able to communicate what the question, what the issue about the data. You should have good communication skill and problem solving skills and willingness to learn new concept in the data engineering. So this is all about the data engineering as a skills. We will move ahead for the Google Cloud Services. So first, uh, GCS. So GCS is Google Cloud Storage. So it is actually service for storing your objects in the Google Cloud, and an object is immutable piece of data, so that you can consist of file, any format. You can store objects in containers. So containers are like buckets. So you will store different objects into buckets. So objects are stored into buckets, and buckets name that we are giving should be globally unique. And we can store unlimited objects in the bucket. And we have some precautions for that. So maximum size, object size should be 5 TB, but you can store unlimited number of objects. So all buckets are associated with project, and you can group your projects under that organization. So if you let's take example, if you have the organization named as ABC, and if you have the different projects, so every time when we are going to the GCP, you need to first create the project. So you can associate your project A, project B, and project C to the your association, which is ABC. So we can do in that way for the cloud storage. Talking about the storage of all types, like we can store text file, binary files, and backup, and even archive sometimes if we want. And we can even backup of your database and storage database. So let's take example for the GCS of your GCS use case. So let's assume that you are moving the data from the on-premises to the cloud storage, cloud database migrations. Actually, you are doing cloud database migration. You are moving the data from on-premise to the cloud. So in that way, you should have the cloud storage, which is specifically in your cloud from the for taking the data, for extracting the data from the on premises. And so we have different types of the storage in GCP. First is standard storage, which is good for the hot data that is accessed frequently, including websites, streaming videos, and mobile apps. So here is like we can access the data frequently with the help of standard storage. So we need to configure this storage when we are creating like bucket. So at that time we can give this configuration. After that, we have nearline storage, which comes at low cost, and it is actually good for the data which we can store for at least 30 days, and so that we can access after the 30 in the 30 days if we want. And including the data backup and long tail multimedia content, we can go with this approach. After that, we have cold line storage, which comes at very low cost. So it is good for the data that can be stored at least 90 days, and it includes disaster recovery as well. At the last, we have archive storage, which comes at the lowest cost, and it is good for the data that can be stored at least 365 days, including regulatory archive. So we can archive the data. And after that, let's assume that you are just putting the data into cloud storage. But do you know, like we are also encrypting the data. So for that, we are using cloud storage, uh, which always encrypts the data on the server side. So we have two different types of keys. First is Google managed encryption key. So when you are putting the data from the putting the objects into the bucket, while uploading it actually uses Google Cloud managed key. And so it is default, we don't need to configure this key. But if we need to use customer managed encryption key, we can go with the cloud key management service. We can create that key, and we can use and we can configure that key when we are uploading or for the encrypting the data. Moving ahead, for the BigQuery, we have BigQuery service from the Google Cloud platform, which allows us to produce the data, manage the data, and distribute and query the data. So this is what BigQuery gives us, and even we can perform the data warehousing. So so 1 minute, just. when to use BigQuery, and what is the use case with Hadoop, and its what is the use of the BigQuery. Talking about the BigQuery, if we are specifically going for the BigQuery, it enables us to run the petabyte scale queries, and even we can receive the results in the seconds. So we can run the petabyte scale queries and we will get the results in the seconds. After that, we can take the advantage of the fully managed system, as it is BigQuery is fully managed system. Just with the BigQuery, you can analyze large amount of data and use cloud-based parallel computing to fulfill your big data demands. So you don't have to worry about actual infrastructure or hardware administration, because it is a serverless architecture that BigQuery follows. Now next point is when to use BigQuery, right? So BigQuery is designed specifically for conducting complicated analytical queries. So it would pointless to run the queries for the simple aggregation or filtering. So in relational database, the best result come when you have the queries that take more than 5 seconds to complete. So BigQuery is designed for the actual heavy queries, those that requires the large amounts of data. Now, if we are comparing Hadoop with BigQuery as a use case, so BigQuery is a serverless, but Hadoop is not serverless. For Hadoop, whether it is in cloud or on premise, you are responsible for the scaling your capacity by adding the additional nodes. And with the BigQuery, Google is responsible for the scaling, and there is no concept of node in the BigQuery. So most important part is in the BigQuery there we don't need to manage the nodes, and we don't have any concept of the node. But in the Hadoop we have the concept of node that we need to scale your capacity with the help of additional nodes and all those things. So and after that, after concept of node, it actually makes easier to manage, and it actually Google BigQuery is a database, whereas Hadoop is a data processing platform. So we will process the data in the Hadoop, and in the BigQuery we will just even we can store the data in the database. With the BigQuery, you can import the data into BigQuery database. So we have some advantages of the BigQuery. It is actually fully managed platform that offers high availability without requiring downtime for the upgrades. And even it is serverless, so we don't need to manage any infrastructure and all those things. And it has low storage cost for the very large data sets. And one more point is we have BigQuery Omni, which allows you to query the data from the Azure, AWS, even from the GCP. So it excels at evaluating massive data volumes and employs AI or artificial intelligence to optimize the storage automatically. So we can even attach the AWS or Azure with the help of BigQuery Omni. Moving ahead for the data flow, data proc, and data prep. So first we will talk about the data flow. It is a serverless data processing service which is actually used for the streaming and batch the data, and it is based on the Apache Beam open source SDK. So it is SDK, and it is actually used for the making your pipelines portable, and we are using Apache Beam as a open source. After that, we have the cloud data prop, which is fast and easy to use. We are running Apache Spark and Apache Hadoop clusters in a simpler and more efficient way, and operations that used to take hours or days, we can simply run in seconds and even in the minutes, instead of days or hours, with the help of data prop. And it is actually cheaper than building your own cluster, because you can spin up data proc cluster when you need to run the job and shut it down afterward. So you can only pay when job is running. It is actually pay as you use service. It is actually integrated with other Google Cloud services like Google Cloud Storage, BigQuery, and Cloud Bigtable. So it's easy to get data into and out of it. So after that, we have the another GCP service, which is Cloud Data Prep. It is actually an intelligent data service for visually exploring, cleaning, and preparing the data for analysis. So we are actually preparing the data for the analysis from the data prep. And data prep is serverless and works at any scale. There is no infrastructure to deploy to, and even for the manage to infrastructure. It is actually serverless, and we can easy prepare the data with some clicks, and even we don't need any code. So moving ahead, just we will take difference of all three services. First, data prog and data flow versus even the data prep. So all these data prog, data flow, and data prep is mostly related to the processing the data. So data prog supports the manual provision to the clusters, whereas data flow supports the actual automatic provision of the clusters. So and even if we are talking for the data prep, it helps to prepare and clean the data for the future. And if the system is more Hadoop dependent, then it is wide to choose. Like, so we can use the data proc over the data flow and data prep, because data proc is created as a extension service of the Hadoop. So if one prefers hands-on approach, then choose the data proc. We need to choose the data proc inside when we need to go with the hands-on DevOps approach. And if we need to use serverless approach, then we can simply go with the data flow. And if we need simply preparing the some just simply preparing and the cleaning the data for the future use, just we will use the data prep, and which is also UI driven. So we can, it's like user interface driven. And as we already seen before, like many prefer the data flow over the data proc and data prep, because data proc is easier to use compared to the data flow. So in contrast, data prep is just only seen for the data processing tools. More important points, like just to cover all the points, real-time database collection you need to do with the Hadoop or Spark integration feature, you will go with the data proc. After that, just you need data lake or data collection or cleaning or cloud in a highly rated way, then you will choose data flow. And if you just need visual analytics and processing the data with the help of data prep, it is the plus point. So at the last, in terms of the portability, we will just simply use data flow for the merging. We can use data flow which merges programming and execution models, and this way it achieves the data parallelization and the more portable than data proc and data prep. Just moving ahead with the cloud composer, which is another service. It is actually built on the Apache Airflow. And Apache Airflow represents actually free and community driven powerful solution that lets team express the workflow as a code. Everything we will express as a workflow. Here we will just schedule the task, and cloud composer will be there to run all those tasks. So it acts as an orchestrator, a tool for the authoring, scheduling, and monitoring the workflows. And Airflow's primary functionality is to make the heavy use of the DAGs. DAGs means directed uncyclic graphs for the workflow orchestration. Actually, Cloud Composer comes with built-in integration tool with BigQuery, Dataflow, Dataproc, and even cloud storage and other services as well. It is actually used with Python code. Airflow allows for the representation of DAGs as a Python code. So we will use Python in the DAGs. which is directed acyclic graph, and it is actually fully managed. Cloud Composer's managed nature allows us to focus on the authoring and scheduling and monitoring different workflows as opposed to the provisioning resources. So here we can see the example, right? So here Cloud Composer is there, and we have different services. First is cloud function, after that we have cloud storage, after that we have data prep, after that BigQuery, and inside, after preparing the data from the data prep, we will send the mail, and at the last we will just take the insights from the different tools like Data Studio or Looker or BigQuery ML. So here actually Cloud Composer comes in the picture for the scheduling all the workflow. First, Cloud function will be triggered. After that, some code inside the Cloud function will do something on the storage, which will store the data or load the data into data prep, and after that data prep will process the data, clean the data, and it will give the data, it will load the data to the BigQuery, and at the last, with the help of BigQuery, we will just gain the insights with the help of SQL queries from. So this is actually we are doing from the Cloud Composer. So if we have uh, something like, if we are running some parameters like some task we need to do at 2 p.m. at night, 2 a.m. at night, so we will just schedule the tag, we will just use the Cloud Composer, and automatically it will trigger the cloud function, and it will process the all workflow as we have given in the Cloud Composer's tag. So this is just explanation for the Cloud Composer. Let's move ahead for the workflow orchestration, how workflow orchestration will work. So actually the primary functionality of the DAG is to just use the heavy, just makes the heavy use of the directed acyclic graph. So for the workflow orchestration, it is just, we will use any graph where the vertices and edges have the same order or direction. Here we can see just it is going ahead, it is not coming back. So it is directed acyclic graph, it doesn't have any cycles present in that. So it is actually a directed graph without any cycles, that is like no vertices that connects back to each other. We can see there is no any other vertex that connects back to the any other task. So here we have the first start, and after that another task. Just first I will explain the airflow DAGs. Airflow uses the DAGs to represent the data processing, and each vertex of the DAG is a step of processing. Each edge is something relationship between the objects, and the nature of the airflow makes a great fit for the data engineering. So since it creates the structure that allows simply enforceability, like simply uses of the modularity and the direct association in the two different tasks. So if we see here, we have the start, after that we are just going to the task 1 and task 2 simultaneously, and after completing two tasks we are going to the some other task, and after that we are just going to the another task 3 and task 4, and at the last we are ending. So this is the workflow, this is actually the flow of our tasks. So this is the first task which is start, after that it will just go to the operation 1 and operation 2 simultaneously. If operation 1 completes before operation 2, it will like some other task will wait till operation 2 will complete his task, and after that after completing two tasks like operation 1 and operation 2, some other task will start, and after completing this task it will just go ahead for the next process like operation 3 and operation 4, some what we can say, and at the last we're just ending the process. So this is how we are just scheduling different tasks with the help of Cloud Composer. So I hope you got the idea about the Cloud Composer, how the Cloud Composer DAG will work, and we are writing all these DAGs with the help of Python language only. So just moving ahead, we have different service which is services for the data ingestion, which is Cloud Pops Up. So actually Cloud Pops Up is publish and subscribe model. So it is designed to provide reliable and asynchronous messaging between the applications. So publisher publisher just applications the can send the message to the topic, and after that other application can subscribe to that topic and then receive those messages. So just BigQuery will publisher, like publisher, we have the publisher, subscriber, and inside that in between we have topic. So publisher will publish the topic, and those who have subscribed for that topic, they will receive the messages from that subscriber. So next, moving on, we have another service which is BigQuery data transfer service, which automates the data into BigQuery on a schedule managed basis. It is actually scheduled because after you configure the data transfer service, the BigQuery data transfer service automatically loads the data into BigQuery on a regular basis. So the if we need to load data on a regular basis, let's assume that every Monday, Tuesday, Thursday, on like basically on 5 day we need to load the data. So we can use data transfer service so that we can load the data on a regular basis and specifically a time. After that, we have storage transfer service, which automates the transfer of the data, or even the transfer from the data between the objects and the file storage. It will just transfer the data from object to the storage systems, and it includes Google Cloud Storage, Amazon S3. It Amazon S3 is just a S3 similar like cloud storage. It comes inside the AWS, and Azure storage also the same cloud storage comes in the Microsoft Azure. And even we can play with the on-premises data when we need to transfer data from objects to the file system. We can do with the help of storage transfer service. And let's assume it, like if we need to transfer the large amounts of the data quickly and reliably, we can do with the help of storage transfer service, and it doesn't require any code to be written. Lastly, we have just IoT core, and even we have use case like migrating data to the cloud storage. So if you have the on-premises data, so we can store the data, we can move the data to the cloud storage. After that, we have the IoT storage, which is actually just a fully managed service for the managing IoT device. So these are all the services that from there we can just simply ingest the data to the different services like cloud storage and all those things. After that, we have Cloud Data Fusion, which is fully managed cloud native enterprise data integration service for the quickly building and managing data pipelines. Okay, so Cloud Data Fusion Web UI just lets you build and scalable different solutions to clean, prepare, and transfer the data without having to manage the infrastructure. After that, we have a like it is the platform. Next, we have data catalog. So here we are just we need just we are just taking a view on all the data sets. Data set is actually we need to create in the BigQuery. It is first when we are creating data set, it is mandatory for creating the data set. If we need to create the table in the BigQuery, so it is scalable, fully managed metadata management service. If we are, and here we can see the diagram. So technical metadata for all BigQuery data assets like dataset, tables, and views is synced into data catalog on a continuous basis. Okay, and this means you can start using data catalog instantly. We don't need to deal with any tedious setup. Okay, and just we need to use data catalog will which will auto syncs technical metadata from pubsub and user created file sets from the cloud storage. Just moving ahead, we have, so till now we have completed different cloud services which is required for the data engineering. Now just moving ahead for the storage and database services, before moving for the uh, building the scalable data analytics pipeline. So we have storage and database services. So it actually divides into four different parts. First is object. We have, after that, relational database. After that, we have non-relational database, and at the last, we have the over data warehouse. So in the object part, we have the cloud storage. So here we will just simply store all the objects in the buckets. After that, we have the relational database. We have, if you have the small volume of data which is just for the something for the e-commerce data, or some, it is actually good for the web frameworks. If we need to just use the small amounts of data, so small volume of data, we will just go with the cloud SQL. After that, we have cloud spanner, which is little bit more, and it is just a integrated version of the cloud SQL where we can run big amount of data. Actually, we can store the big amounts of the data in the cloud spanner, and it is actually good for the relational database and even HA and HTTP. And here we have the user metadata, like fin different type of data, metadata for the different large volumes of the data. If we are just, we will move ahead for the non relational data. We have CloudStone and Cloud Big Table. So CloudStone is good for the hierarchical and mobile and web data. So here, like, we can store the data like user profiles, even the game state. Like if we are talking for the object storage in the cloud storage, we can upload the images, media, and even the backup of some services as well. So in the cloud SQL, we can store the CMS e-commerce data. In the cloud spanner, we can store the user metadata, and in the clouds files Firestone, we can store the user profiles as it is no SQL, and even we can use game state as well. Talking about the big table, it is actually heavy read plus write data. We can just use the heavy data over here with and which is non-relational, and we can upload the financial or IoT databases, IoT logs, and all those things. Talking about the warehouse, we have BigQuery, which is just a simple approach for the ETL. It is good for the enterprise data warehouse, and we can do analytics and dashboard with the help of BigQuery. Moving on the last part of our session, which is building a scalable data analytics pipeline. Just we will see how we can build scalable data analytics pipeline. So till now we have discussed different services, Google Cloud services. First is capture. So just for your understanding, I'm telling, first we are capturing the data uh, with the help of data ingestion at any scale. After that, we are processing the data with the help of data flow, data proc, and data prep. So here we will process the data on a reliable streaming of the data pipeline. So first we have data flow. So we can stream, and we can use data flow for the streaming and batch processing. If we are just we are more intended to the Hadoop or Spark, we can use data proc over there. And if we are more intended to just preparing and taking a look on that data, we will just simply use data prep. So before that, how we will ingest the data from different services, we have covered the cloud pops up, which is actually messaging platform. So if you have the publisher inside, like in between publisher and subscriber, we will have the topic. So here we will just publish the topic, and those subscribers will get the message, those who have subscribed for the topic. After that, we have the data transfer service. Just we will just do the fast data migration from the SaaS application, which is software as a service application. After that, we have storage transfer service, which is actually used for the data migration from other cloud, or even we can use from the on-prem as well. And at last, we have cloud IoT core. It is actually used for the streaming events from the IoT devices. So here we are just ingesting the data from different sources. Now here the next step, this is the capture step. Next step is processing different data that we have. So here we are using cloud flow, data proc, and data prep. And after that, we are storing the data into data lake, or like we are using data lake for the raw data. And if it is processed, we will use just data warehouse. So if it is a data lake, so first is cloud storage, which is just like simply raw data. We can use as your data lake for structured or unstructured data. Here we can store all the structured and even unstructured raw data inside the cloud storage. With the help of uh, buckets, we can just simply store the objects. After that, we have BigQuery storage, which is actually cloud native and highly scalable serverless data warehouse. Here we will store the processed and structured data in the BigQuery storage. At the last, we will just run the analyze step. So this is the fourth step, where we will analyze the data by with the help of queries. So we will just extract, just get insight from those all data with the help of BigQuery as an analytics engine. And at the last, we can move ahead with the advanced analytics if we want, like cloud AI platform or TensorFlow for the machine learning. Even we can use Looker or Sheets for your analysis as well. Most importantly, we are all doing this process with the help of cloud data fusion, which is just integration service for managing ETL or ELT process. ELT and ETL is it just like ETL. In the ETL, we will just do ETL, extract, transform, and load. And ELT, we will just do first we will extract. After that, we will load, and at the last, we will transform data. So that we can do with the help of data fusion. And with the help of data catalog, we are we can view all the data sets, whatever the data we have for the whole process. We can view the all the data set with the help of data catalog. And at the last, whatever we are doing, when we need to set up capture step, when we need to set up process step, when we need to set up store step, analyze step, and advanced analytics, all this is doing with the help of cloud composer. So just for your understanding, here we will schedule the DAG that will just ingest the data from the different sources. So this is where we will just ingest the data. After that, over here we will just process the data, which will be scheduled for the whole data analytics pipeline. So this is like after scheduling the DAG, let's assume that we need to schedule the job at 9 p.m. for the cloud pops up. So let's assume we will get the some data at 9 a.m. For the so at that time, whatever the data will come, we should move that data for the next process, right? So we can schedule that pubsub DAG at 9 a.m. And let's assume another task we have, that for the data transfer service we are getting the data at 11 a.m. So we can just schedule the DAG at 11 a.m. for the data transfer service. After that, we have just, let's assume we have another task that gets the data at 1 p.m. or 1 a.m. So at the different times, we get the different data. So for the cloud pops up, it will just start the process. After that, it will go to the data flow. Whatever, if it is related to the stream and batch processing, it will start from the data flow. If it is related to the data proc, it will go into the data like Hadoop and Spark platform. And if it is related to just for the preparing the visual tool, just it will go to the data prep. And at the last, it if it is structured, okay, so it is if it is structured, it will go to the BigQuery storage. And if it not structured, it has the raw storage, it will go to the cloud storage. And at the last, it will go to the BigQuery. So when we are triggering the cloud pops up, at that time it will just start the DAG, and it will process all the DAGs automatically. We don't need to go into data flow for the streaming and batch processing. We don't need to go into the cloud storage for the loading the data, either data lake or something like BigQuery storage. And even we don't need to query the different data. Just we need to schedule the DAG with the help of Cloud Composer, so that just we are orchestrating all the flow. So this is the flow for the data pops up. Let's assume cloud pops up, data flow, cloud storage, BigQuery. This is one flow. After that, cloud data transfer service, Hadoop, cloud storage, BigQuery. This is another. So this is another flow. So we can just orchestrate all these flow with the help of Cloud Composer, and we can just schedule on the timely basis. So this is all about data engineering on GCP. And just for the additional purpose, if you have any questions, let me know.
Participants, you can unmute yourself and you can ask the questions. So, Mahesh, a few questions are there in the chart.
Okay.
Which service run faster, data flow or data prop?
Yeah, data. So mostly related, if you are talking, I hope my screen is visible. So here I told, it's mostly related to the what your use case is. So your question is for the data proc and the data flow, right? So if your data is mostly related to the data science or ML ecosystem, and then we will just go with the data proc. After that, if you have the data which is mostly related to the streaming and processing the batch data, we choose the batch data. But it is relatively difficult as compared to the data proc and data prep. But data flow will run as faster from the data proc.
Yeah. Another question related to cost. That is, if you are using data prop along with big table, it is costly, or along with BigQuery, it will be costly. That is, data is same cost if you use big table or BigQuery.
Okay, it actually depends on the querying the data. So if you are query, like if you have the one query, and if you need to get some analyzing from that. So when you are running the query, at that time only you will get the like you need to pay for that query. It's not like you are using storing the data, and just for the storing you will get the in the BigQuery. I'm saying, if you are talking for the Google Cloud Storage, we have different storages. And it is at like, this is like something costly standard storage, and archive storage is like little bit low cost. And in the BigQuery, when you are querying the samples SQL query, then at that time only it will cost for that query, for running the query. Any other question? Which service runs faster? data flow is okay. This is data prep is same cost if you use BigQuery. Table. Okay, no, data prep is same cost. No, it's not like when we are using BigQuery, we are just using BigQuery for the ETL process, like extracting, transform, and loading the data, and even we can gain insights from that. And when you are preparing the data, it costs differently. If we are talking for the BigQuery and data prep, it's not like same cost we will get. Okay, I hope there is
Participants,
no.
yeah, participants, any more questions? Yeah, let me see. I have shared the link for downloading the certificate along with the speaker code. So, audience, the speaker code is 924L8478L. So, once again, I will repeat. The speaker code is 92478L. So, now I will show you how to download the certificate. You can go to www.fifthir.com, or you can click the link which I have shared in the chart. You can go to events. Now you can find multiple events available in Fifthir. This is upcoming events. You can find these events over here. Now you can click this view events. So now you can log in for this event, or you can register as a guest. Now I am registering as a guest. So now I'm going to provide my name. So now you can register. Yeah. Now you can find the option that is claim certificates. For claiming the certificate, you can click this option. And again, it will ask for the name to be displayed in the certificate, your corresponding mobile number and the email ID, to which you have to send the link for downloading the certificate. So now just you check this. Now click next. Now you can provide the code, speaker code. So again, I will repeat 924L8478 is the speaker code. Now I will paste it over here. Now next, submit. Yeah, it's done. Okay, certificate is generated and it will be sent to you. The link for downloading the certificate will be sent to your mail ID. Okay. That's all from the certification desk. Hope that you enjoyed the session. And again, on behalf of Multi-Cloud for you, we like to thank Mahesh for giving a high-level introduction on data engineering tools available in Google Cloud Platform. Once again, on behalf of Multi-Cloud for you, we'd like to thank Mahesh for giving a wonderful session on data engineering in Multi-Cloud in Google.